Welcome to the first episode of our physics series. In this episode, we're going to start to lay the groundwork for tracking motion. Physics, we've said, is the study of how and why objects move and interact with each other. And so we're going to start today by trying to establish a way to track the motion of an object. Because if I want to study the motion of the object, the first step is I have to be able to track it. Now, for today's talk, that means we're going to talk about a couple of really important quantities. The first thing we're going to talk about is position. Then we're going to talk about displacement. And last, we're going to finish up by talking about velocity. So let's start by talking about position. Position in physics terms is really simply just where an object is. I need a way to communicate where this car is on the track. And we're going to start with something like a car on a track because it's a really simple one-dimensional situation. For this kind of problem, all I have to worry about is where it is on a number line. So that's exactly what we're going to do. We're going to establish a number line, and we're going to put numbers along that number line that we can use those numbers to track where the object is. Now, to start doing that, the first thing I have to decide is where I want 0 to be. Now, where you want 0 to be is a bit of an arbitrary decision, but you could make that decision to make your life easier when we start doing some mathematical analysis. We'll leave talks about that for later. For now, I'm just going to establish my 0 right in the dead center of the number line. Now that we've established our 0, I need to establish all the other numbers. And again, I have a choice here, and I can make that choice to make my life easier. I can decide which end of the number line is going to be positive and which end is going to be negative. For today's video, I'm going to keep it simple, and I'm just going to make the more kind of conventional situation that way positive. And I'll make that way negative. So give me a minute to put some numbers up on the line. Okay, so now that I have my number line established, I can very clearly communicate where my car is at any moment. So for example, right now, it's at -3. I had to think for a minute, I forgot which side I made negative. Right now it's at -3. I could move it to 0, and I could move it to +3. I can move it to +2. And now you can always keep track of where my car is. I'm going to take a second to make a quick note on units and variables, because in this class we want to measure everything really clearly, and we want to communicate all that very clearly through math. Now, I've just put some numbers on a number line so we can get a sense of the basic idea, but in this class we're going to use units of meters. It's really important to understand that no matter what we do, our equations are all set up to work with meters. So it may make more sense for a situation like this to measure in centimeters, and that's fine. But we have to make sure we convert before we use our equations. On another note, when we communicate these ideas mathematically, I need a variable to communicate position. And for this one, it's really simple. For my horizontal situations, I'm going to use the variable x. For my vertical situations, I'll use the variable y. Now that we've established our number line, I can get into starting to actually track the motion of the object. I may want to communicate that I started at +3 and ended at -2. And for that, I need a new idea. And the idea we're going to use is called displacement. Displacement, as its name suggests, is just a change in position. It's simply where I was versus where I am now. Mathematically, we describe displacement using the variable delta x. You may recall from your math class that delta just means change. So delta x literally just means the change in position. You may also realize at this point that vertically we'll probably use delta y. So delta x is the change in position, and mathematically I could write out a formula to find it. And if it's a really simple idea like change in position, then the equation is really simple. I'm going to take my final position and I'm going to subtract from that my initial position. And when I write out the equation, I'm going to use a subscript f to communicate my final position, and a subscript I to communicate my initial position. Thus, the equation is going to be delta x is equal to x sub f minus x sub I. Since I measured both my final and initial positions in meters, then it probably stands to reason that my unit for displacement is going to be measured in meters as well. Now, displacement is a vector quantity, which means that it has both a magnitude and a direction. I care how much, but I also care which way. So in my number line situation, it's really simple. If my displacement was in the positive direction of my number line, then my displacement will be positive, and that communicates the direction. If it was in the negative direction, my displacement will be negative, and that communicates the direction. So it's pretty simple stuff. And if you use the equation, it'll actually take care of all the hard work for you. Let's look at my example. If I start at +3, and then I move to -2, well, my final position is -2, my initial position was +3. So using my equation, final minus initial gives me -2 minus +3. Quick math in your head would tell you my displacement was -5. Negative direction, and that's what we saw. Negative displacement. So your equation will take care of the direction for you. Now there's another similar idea out there that's not a physics quantity, but it is something that you're going to want to take note of, and that's distance traveled. Distance traveled is defined as the distance that you traveled. Okay, so displacement is defined mathematically as final position minus initial position. I don't care how I got there. All I care about is where I was and where I am. Distance traveled, on the other hand, is going to take into account the entire journey. Let's look at an example. So let's say you're leaving my room to go to lunch. Well, you could take the quick, easy path all the way down the main hallway to the cafeteria. And if you do that, you have a very short distance traveled. But let's say that you decide you're going to swing by Mr. Butler's room on the way. So you go around the whole big square. Well, when you go around that whole big square, you're going to travel a lot further. Eventually, you'll still end up at lunch in the cafeteria. Your final position is cafeteria. Your initial position is my classroom. Your displacement's the same in both cases. However, in the case that you go to visit Mr. Butler on the way, your distance traveled is significantly higher. So that's going to be an important idea when we move forward. Okay, so we've talked about how to tell where an object is. We've talked about how to tell where an object has moved. Let's talk about the last thing I may want to know. Because two examples of motion that are very different. If I start at -3 and then take a very long time to get to -2, that's different than if I start from +3 and very quickly get to -2. And we're going to want to be able to tell the difference. And for that, we introduce a new quantity. The quantity we're going to talk about now is velocity. Velocity is also a vector quantity. I care not just how much, but also in which direction. And it's going to help us describe how quickly I have a displacement occur. So if you think about it just a little bit, we could just come up with that idea on our own. I have a displacement, I want to know how quickly it happened. So I'm going to take that displacement, I'm going to divide it by the amount of time that it took. So let's define velocity this way. I'm going to use the variable v, and I'm going to say it's equal to displacement, delta x, over my change in time, delta t. And that's it. That's how we'll calculate velocity. Now a quick note on units then. So we do a quick dimensional analysis. Delta x, our displacement, that's measured in meters. Divide that by time, measured in seconds, and you get units for velocity of meters per second. Be aware that your equation will determine the direction for you, assuming the sign of your displacement is correct, because the sign of the displacement and the sign of the velocity will necessarily agree. Okay, now we have one other idea that I want to introduce here, and this is not a physics quantity, but it's an important thing that you need to keep track of, and that is speed. So speed is essentially the non-vector form of velocity. For speed, I don't care about the direction. All I care about is how much. So speed's a very similar idea, except that it's not a vector. All right, guys, that's it. That's all you need to be able to get started tracking motion. We talked about position, where a car is. We talked about displacement, how the car moved. And we also talked about velocity, how quickly the car moved. Those three ideas are going to get us started learning about how to track motion. There will be a couple other important ideas as we move forward, but that's really the basis that you need to get started analyzing motion. So I'll see you next time when we introduce a new idea, acceleration.